Well folks, I'll just shift some of this gear. We've got a Team 3100 base station here, which is actually mine. And the reason we've got this here is because I've had a customer's gone on for 6 days. I've only been able to spend 6 45-minute sessions on it, so it's still a lot of time. And what happens is with the customers, you switch it on, and after 2 or 3 minutes it stops transmitting. The reason being it's going out of lock. But when you actually monitor what's going on, there's been quite a number of faults, including transistors on this subboard, transistor on the main board. We did change the phase lock loop chip as a precautionary thing, including this cable where it's been factory terminated, having the insulation migrate into the outer. So lots of snags. So what we're going to do, it's still a problem, and I'm wondering if we've got a duff part in the wax department. Well, these are plated through printed circuits and difficult to unsolder anything at the best of times, and I just think it may be, if I can get this to work, this is ours, this is his mic, this is our set, it may be better for him to be offered this one instead. So let's see what needs doing to this one. Well, it's lit up. These things start off on channel 9 because they are specially intended to be annoying. The squelch works on this, which didn't on his. Right, so let's start again. Now, whether or not we're going to put it depends what happens. Depends whether we show the video of us getting so far with it or not. I've had to dig a lot of paperwork and do a lot of research. And the thing is, when these work, you know, that nobody I've ever known likes them. So don't get excited. So these always are going to be problematic insofar as you've got this crystal mixer, so you've got to set 10.24, you've got to set the transmit, then you've got to set the receive with the second signal generator. So it's always going to be a pain in the what's-it to set up. But this is, we bought this about 4 or 5 years ago. It's been stuck on the shelf ready to do a video on, and this seems an ideal opportunity. And if he has this, then he has this. If he doesn't have this, we'll stick it on eBay, because I don't need to have one. We've got the one with a meter already in stock. So let's have a look at whether it transmits. Well, I'll tell you what, it would be really handy if I plug the aerial in. And it would also be handy if I plug the test equipment speaker in so we can get some readings. This 5-pin socket on the back is for optional selective calling. And I've shown you that some years ago. Right, channel 20, and we have got it's on variable RF power, which is kind of interesting. So what have we got? We've actually got 4.6 watts, which is more than his set's done even after a tune-up. In the 3 minutes it works. That's going to have to come down. And on channel 1, 4.8 watts. And on channel 40, it's bound to be, I'm going to make a guess, it's 4.4 watts. No, it's 4.6. Low power isn't like that on these, it's a constantly variable power. And on this radio, put into the bottom end of low power, it is 650 milliwatts. So strictly speaking, these weren't going by the book as to how it should be. I don't know what the current is because it's a built-in power supply. So let's look at a quick deviation check. Oops, needs to go back to channel 20 for that. Wallow, wallow. It's 1.6. But we'd verify that with the test set behind me in case this is playing silly what's it. So we'll just go into, now normally we'd say what's the transmit frequency, and then the signal generator will set to match. But because this transmit and receive are totally separate, the way the frequency is set, we'll have to go for the proper frequency on the signal generator. So 27, 7, 9, and on top of that, when his set has been receiving, it doesn't sound right, as if it's got a filtering issue. So, you know, it's getting up there, isn't it? And this one hasn't been nicotined in, whereas his has. Right, so with that, let's look. Well, first of all, while we've got the signal generator, while we've got the frequency counter on, we'll go back to transmit, and we'll see what it's transmitting on. 2779104. Well, it's not hardly anywhere that. 2779104. Receive is doing what? See all the fairy lights lit up. Right, let's switch the cyanide meter on, put that up on the camera, and move it a little bit. Turn the squelch down. See, this sounds right. So for 12 dB, it's doing oh, 0.45. For 10 dB, 0.43, and for 20 dB, it's doing 1 microvolts. So when his set was working, when it is working, in those minutes before it plays up, so we had 3.2 watts, and we had 0.8, not 1 microvolt, and it never did 20 dB, which is why I think it's got something wrong with the filtering in the receive, because it's not the detector that's out. So there's a lot still wrong, even if we get to the bottom of, which I don't think we will, because it's going to be a fault in the wax thing. The thing is, we can't spend hours with a hairdryer getting all this wax out. It's just not worth it on a set that isn't worth much. Squelch. Pretty wishy-washy the way that's just come up. 1 microvolt for full. Mind you, his other set didn't work at all, does it? His other set, he only got 1, it's the other one. Set threshold. It's 0.58. Not ideal for base station. So let's go through it. Right, I've got some notes. I'll worry about the frequency in a bit because it's so close that that's not going to affect the way the transmitter is going to be performing. So transmit, we start at transformer 14. I've got some printouts. So these mid to late 90s, last base station apart from the Team 8000. I've never seen a Team 8000 that works. We've got two here that don't. It's that way on, isn't it? So we're looking at transformer 14. Twelve, 11, 7. 7, where's 7? No idea. Anyway, it's a 2 under there. I don't think we're going to get any. I really don't think we're going to get any improvement. So we'll just start with that one. Spot on. Spot on. So far everything's been spot on, and with that power output it can't be that far out. Let's go to full power. There we go. Not sure what the German is for some of these. I think that's going to be the power meter. Yes, it is. So I need to set this to full power. And it's over the top, so I'll set it to that at the moment. Not sure how we turn it down except by detuning that. So we'll come to that in a moment. So TX meter. That one is TX meter. That's going to be RX meter. What's hub? Is it squelch? And what's peggle? And what sense? No, sure. I'll just see whether we've got deviation. I'll get the meter out, the oscillator. I've been showing you the wrong meter all the time, haven't I? So we'll go over to the right meter. So there's our transmit, just over the 4 watts. And now we'll go to deviation and see whether it's hub. It is. We'll turn that to full in the hope that that's somewhere near. We'll go over to the test set behind me. Voila, it's not ready. I'll pause the video and come back in 5 minutes. I'll give that a bit more time to warm up. It's not ready yet. We'll get on with the receive instead. I'll tell you what, we'll set the frequency. So use our oscilloscope. And what we'll do is we'll go to pin watt of the, for our 10.24. We're going to monitor it on the receive IF chip because it's an easy place to get to. Then we can adjust the 10.24 if necessary. So when you look at the circuit diagram, the 10.24, which is the master oscillator for the MC145106 synthesizer, has an output which goes up to pin 1 via that capacitor. So that's the 10.24. So pin 1. Have we got a probe on the end of this? No, we haven't. Are we bothered? No. Pin 1, poke that down there. Hopefully that's going to be in the picture. So 10.2396. Just press auto so it is somewhere near. There you go. So that needs to come up a fraction. So this is the first thing to do to adjust the frequency. So with the trimmer capacitor for the 10.24 and our frequency counter on that pin 1, it's actually gone. 10.24, spot on. So now, remove that. We can go over to the, not even got picture in picture on, have I? We'll go over to the frequency counter and we're going to transmit, and now we can see what the real frequency is. 2779,103, which is hardly any different to where we were before. I can't remember whether it's this is the transmit one or that's the transmit one, but it really doesn't matter because whichever it is, I think I got it right. A little bit high. Despite using a ceramic tool, it's affecting it slightly. Spot on, 2779,125. So that's that done. Anyone seen the pen? There it is. So we're at 2779,125. Now, while we're doing this, that one's going to be received. So we need to put a second signal generator on. So I'm going to have to dig out my little Chinese one. Okay, well, we've had a power outage this afternoon, and 3 things crashed, and one of it was the recording equipment, and I didn't know that had happened, so unbeknownst to me, to stop recording the sound. So we'd got as far as me going to get the second signal generator and using it as a marker oscillator at 10.695, and then adjusting the receive crystal for a null. which I've shown before. I've shown it on this model before. So you didn't see that. Went through the receiver. I think I did show this diagram as to which is which. I'll make sure that's in shot fully for people with screen. The detectors there. 1, 2, 3, 4, 5 to do. Presets, don't know whether we covered that. Deviation, squelch, and the preset squelch says VSQ on the front. VSQ is that back one. I didn't know what that preset was when I did this diagram, but we've learned. And then of course you've got the transmit and receive on this subboard here. So there you go. So you've only got half the video. We've done an on the air test, and it worked satisfactory. I'll publish that as quickly as possible, rather than waiting 12 or 18 hours, and then at least you'll see how this works. So we'll offer this to the customer instead. It's entirely up to him, and if not, well, we'll just stick it on eBay. So there we are. So thanks for watching half a video, and we'll catch you next time.